All right. So this workshop today is on a deep dive into Git, and the focus is on safely committing code. What you all will find is as you get deeper into your personal projects and just in general with programming, projects get bigger, code gets bigger, you kind of get more in the zone. And what always ends up happening is I'm sort of on a late night coding run and I'm getting a lot of stuff done, but then maybe I make a mistake and I want to go back to a previous version of my code and I can't. Or even worse, I delete something and I want to get it back and I can't. And it's sort of part of the natural learning curve of software development. Everyone kind of learns this sort of thing just through getting your fingers burnt. But some of these techniques will be helpful as you go deeper into personal projects and bigger projects. Um, the focus is really going to be here on talking about safe workflows to give you all more confidence for using some more advanced features of Git and focusing on this scenario of I've added or committed code that I actually don't want. How can I safely undo it? Along the way, we're also going to dive deeper and learn how Git works. We'll talk about this concept, the three trees. And we're also going to look at these three scenarios where I've added code that I don't want, but I haven't committed it yet. I've committed code that I don't want, but I haven't pushed it yet. And in some ways, the trickiest scenario of all, I have committed and pushed code that I don't want, right? And we're going to learn how to deal with these scenarios with Git restore, Git reset hot, Git reset soft, excuse me, Git reset hard, and a force push. And I'll talk about the dangers and risks of force pushing. And we'll take a look at how to undo a commit with Git revert, which is actually pretty cool. And I'll talk a little bit about my own workflow with backup branches. Along the way, we'll dive into some Git concepts, the idea of a working directory, the index and head. We're going to talk more about head, which is sort of the tip of a branch. We'll talk a little bit about refs, and how sort of the anatomy of a Git branch with head, refs, and commits. And along the way, we'll look a little bit inside the .git directory, and that's all going to sort of be icing on the cake. If we have time, we might look at cherry pick or rebase, or checking out a previous commit. There are a couple really good resources here. There's some outlines and notes. There's also a pretty amazing site called Git from the bottom up, which I highly recommend. Both Francisco and myself kind of love this site, and it's a really great tutorial and deep dive into Git and how it works. And some bits of this have been pulled from that. Did folks have any questions about the sort of agenda before we dive on in? All right, cool. So let's talk about this scenario. And to do this, I'm going to write some code. Um, so we're familiar with our friend, the command git status. And I really want to be typing this all the time. I type git status like every three commands of the command line, I feel like, whenever I'm working with Git. I pretty much type git status after everything I do with Git. And because I've created a brand new empty repo, we don't have any commits here at all, right? And that's what this message is saying. And this looks like a new VS Code feature, this sort of autocomplete thing. It's nifty. It's adding a lot. And a git log would show me a history of my commits, but we don't have any commits yet. So let's go ahead and let's start adding some code that we don't want to commit. And then along the way, we'll see how to deal with it. So I might be working on a Python project, and I might be creating a virtual environment. And I'm going to create a new virtual environment named .venv in my directory. We'll talk about the .git directory that Git uses later. Um, and I've got it, and let's go ahead and let's activate it. And I now see that my Python virtual environment that I just created is active. Let's go ahead and install some things. let's build a Flask app. So let's install Flask and Flask cores. And I have some guide code that I'm working off of for this. And it would help if I added my install command so that pip knows what I want it to do. And we might as well run pip update. It certainly won't hurt. And now that I've done that, I want a requirements.txt file that lists my Python dependencies. So other coders can also install these dependencies when they're cloning down my repo. So pip freeze prints out the dependencies that I've installed in my Python virtual environment. And if I use this sort of arrow command on the command line, I can put that output, instead of printing it to the terminal, into a file. And, when I'm doing a new project, I want more things. I want a README. And let's open up our README. And let's close that unneeded recursion error file. And we'll just say, we'll just say README. This is my project, README. We'll just leave that there for now. And I'm going to want some directories. I'm going to want a front end, though we're not going to do a lot with it, and a backend directory. And we're going to spend some more time in the backend directory. And let's make a file. Let's name it app.py and let's put it in our backend. And if I look at the files I have now, I have a front end directory with nothing in it, a backend directory, and inside that is app.py, my requirements.txt, my README, and of course I have my .venv file. And I am going to copy and paste some code here from my guide code into our app.py. And I just wanted enough code here that we have something real. We'll see this code again in the other Git workshop, but we have a Flask app here, a really simple student class that has an ID and a name, and a Python list of a couple students. I have a sort of home route that just returns a hello world ping message, and a students route that returns all of our students. And then I'm running my Flask app. And I might as well update my README a bit as well. And again, I have some guide code here because the purpose of today's exercise is not to write code, it's to use Git, but I wanted just enough stuff here that it's real. And so we have some installation steps, we have some run steps, and in fact, I should be able to go ahead and run this. And it would help if I ran it from the backend directory. And it looks like I have an error. I may have forgotten to import Flask. I may just skip that one, to be honest, because we don't even need this to run. And in fact, we can fix this later, and that might be a good commit to add. So I think I'll just make a note here. And we're going to need Flask cores as well. And we can keep on moving. And so I know I got some work to do, but I have sort of a nice skeleton here. So let's go ahead and add my code. And let's go ahead and, well, let's actually pause here because I've been kind of in the zone, and let's see, did we add the .venv directory? Interesting. I actually would have expected the .venv directory to be added here. Um, I'm not sure why it didn't get added. Let's see. I wonder if the behavior of git add has changed recently or if the behavior of git status has changed. Because what I'm used to seeing, and I would love a sanity check here if I'm wrong, is I expected to see the .venv directory in here and then we would remove it. Um, but that's actually, we can still demo this without that. Let's test something out real quick. Let's make a directory named .foo and let's add our foo directory and let's actually make a file. Let's just put something in there. Yeah, interesting. Um, I'm not sure why the .venv isn't being added, but that's okay. We can use this as an example here with this sort of .foo .bar example. And this is the first scenario that I wanted to show, which is this git rm cached to unstage something. And so what I can do is unstage this from the commit that I want to make. And before doing that, let's actually kind of build out this diagram and talk about these what are called these three trees of Git. So everything I do in Git is going to fall into one of these areas. The working directory is literally what I have here in my file system. So we started out with, we had the .venv directory, we had readme.md. I have a front end directory, and let's add a slash at the end so we can see what's a directory. I have backend, and there I have app.py. And now I also made this .foo directory with this file named bar. And every time I add something, Git moves it from the working directory to the staging area, which is also called the index. And then when I commit something, all of this gets moved into the commit tree, which we'll talk about in a minute. And so I can use this command, and they've shortened it now, so it's just git rm and then cached. And this will actually unstage and move something out of the staging area without deleting it. And just for fun, let's open up this foo directory and let's go into this. Let's in fact rename foo bar to be bar.txt, or let's make it a markdown file. And let's go ahead and open it up. And we'll just say this is a markdown file, just so we have something in here. And note, by the way, that that change I made is now untracked, right? We have the old version of this foo bar file name, but we now actually have a new one as well. And in fact, Git is paying attention to the difference between, and let me grab an arrow real quick. If I type Git status, I see changes not staged for commit and untracked files. And so Git is able to look at this difference, not just of a file, but changes to a file. And so I might decide, first of all, I don't want to have these changes for this foo bar file staged at all. So let's do git rm cached foo/bar. And let's see here. And I have a typo. And I see a question. And give me just one moment here. And now if I type git status, we see all of my other changes are here. But I now have untracked files. And because we removed this from the staging area, when I type git status, and git is comparing the difference between what's added to staging or the index in the working directory, um, there aren't different versions of our bar file in there. So we just see unstaged changes for this untracked directory foo. Alex, yes, sir.
It was just a quick question about this git command, git rm dash dash cached. If you, instead of inputting the file name, if you just put a period, would that unstage all of the files that are staged?
I believe that's correct. Yes.
Cool.
And that actually touches on, I think, the first thing about workflow. If I do git rm cached readme.md, if I've made some sort of mistake here with this command, um, it's only going to affect the README file. So my worst case scenario is I'm losing changes to one file. But if I run this command with dots, and I've screwed up my git command, which, as you all know, git, I think it's pretty universally acknowledged, its command line user interface is not the most intuitive. So you guys should assume that you're making mistakes all the time with git commands, because I do and everybody does, and that's called sort of defensive programming. This is a much more dangerous operation, right? Because now if I've made a mistake here, potentially I could have like an hour's worth of work here that I'm putting at risk, right? So there's really no, I would recommend really never using the dot for removing stuff for this RM cached. For adding, you can just add stuff all you want. There's people I know who say you should never use the dot even for that. But for this, it works. Um, oh, it looks like it needs maybe it needs to be a star. Maybe it's not dot. Or maybe I need like the dash R flag like it's saying. Let's see here. There we go. And so now all of that is unstaged. I would not recommend doing that. I would recommend unstaging individual files, right? Because that's a much safer operation. And you want to think about you've been coding for like 3 hours or it's like 10 at night. And what's my workflow that minimizes the risk of making an error here? Yeah, so great question. Right. And it sounds simple, but again, I can promise you guys, you will all have an experience where you will make a programmer error with Git and lose work. And so this is sort of like a hard-earned bit of workflow advice that can make your lives easier. And so now, in fact, we have unstaged everything, right? And everything is back here. And we have all of these untracked files. And now I can go ahead and add them back in, right? And I've added my README file. And let's go ahead and add the rest. And we're going to add actually everything except the food directory because that's the one thing I don't want to add. And again, git status is your best friend here. Again, I'm frankly a little surprised that I'm not seeing the .venv directory move into the staging area. That's what I'm used to seeing. I'll have to investigate a bit later to see if maybe it's there, but it's not being printed, or Git changed its behavior. I might have created a global.get ignore file that I forgot about, and that might be what's doing it as well. Rick, yes, sir. You might be muted, Rick.
There you go. All right. Yeah, I'm sorry. Yeah, I want to say there's a default, um, or it could just be that .env is naturally hidden. Anything with a dot in front of it is normally hidden, so it's usually not committed like .env and .venv. So, but yeah, I have a global state where it doesn't pass any of that to get.
Yeah, it looks like I don't have a global get ignore. I'm not sure what's causing the unexpected behavior, but for our purposes, it's okay. Um, yeah, but I agree. I was a little confused by it. So I've got these changes here, and now I can go ahead and commit them, which we know and love and we're used to. So let me go ahead and commit those changes. And if I add dash M, it lets me type a commit message on the command line. If I don't add the dash M flag, Git will use whatever editor I've configured it to, which should be VS Code that we've done in InstallFest, and I can write a commit message. I could say initial commit, created README and a backend app server, but app py has breaking errors and to do. And Git here, if we want to, has included in the comments. It will add new files or files that are changed. And maybe I want to uncomment these lines. So this is now in my commit message. And when I go ahead and save that, now if I type git status, we see that nothing is in the staging area, right? In fact, all this has moved here and it's been committed. We still have these untracked files. And if I type git log, we now see that we have a commit. And let me go ahead and create a circle and we'll put our circle here and let's make our circle clear. There we go. And let's make our circle red. And so this is our commit and we'll call it, let's just grab the first part of this commit hash that uniquely identifies it. And now I don't have this commit up on my repo yet. If we go to, let me pull up the repository I've been working off of here. Right, I haven't pushed this commit, so let me just go ahead and push it. And now we have our initial commit. And let's keep playing around with this because this is where it starts to get more interesting. I am going to throw a couple more tools into the mix here. If you want, you can use the built-in version control tool that they call source control. And you can see here changes, uncommitted changes. And I have a great extension that I love called Git Graph that I've installed. And if you go to extensions and you search for Git Graph, it will be the first one that shows up. And it shows up if you go to the source control tab, you can see the graph here on the side. If I use Command Shift P to open up the command palette and I type git graph, I can also view the graph here visually. And I can see that I have one change that's happened on my main branch. It's been committed to head, and we'll talk about head in just a minute. Um, and then we have some uncommitted changes. And let's go ahead and let's fix those errors in app.py with Flask. And I need to do a quick reminder for myself. So let's say like Flask, uh, you know, tutorial. And I just want to be reminded, how do I import how do I import Flask? And it should be from Flask, import Flask, I think is one of the commands that I was missing. Right? And that should resolve that bug. And if I run my code, Python backend app py, well, that error is fixed, but we need to now tackle the Flask cores. And I'm just going to Google again, Flask cores install. And I just want to take a quick look at their tutorial. Here's installation, here's usage, and this is the line that I couldn't remember. And let's add this as well. And now we can get rid of this to do statement. And now if I run my code, it should run without error, which it is, which is great. And we could ping here if we want. And now let's commit those changes and let's walk through what happens as we do. So as I've done this, I've changed my Git working directory. Right? If I type git status, I see here app py has been modified. And this is the only change that I want. Again, we're pretending this foo directory is my .venv directory. In fact, let's make a git ignore file. And in here, let's add, even though it seems to be ignoring the .venv directory already, .venv and foo. And now if I type git status, we see that Git will automatically ignore those. But we now have a new file that we've created, this .git ignore file with these changes. So Git knows I've added a new file and it knows I've modified an existing file. Right, and so let's go ahead and git add the changes to backend app py and the git ignore. Git status tells me these are now in my staging area. And now let's go ahead and let's make a change. Let's say that I made a mistake in my code. And I have a to-do statement that I don't want. And let's commit, and let's just write a short message, and let's just say import Flask and Flask cores into app py. Right, and so now these are committed. And so something interesting has begun to happen here. I now have 2 commits on my main branch. And if we go to our Git graph here on the side, we see that I have this commit here. That's the most recent. And behind it, my initial commit. And in fact, by using Git graph and source control, I can look at all of these changes that have happened. Right? And Git can show me the diff or difference between them. And we'll talk about that more in just a minute. And it's got this crazy file name here because it's comparing 2 different Git commits. And it's not my actual file. And we can close that out. We can see the graph here has the changes as well. And to kind of update my TL draw, I now have, oops, excuse me. This commit I made. And this second commit. Right, and this second commit has a commit hash of FBE something, something, something. So we'll just kind of rename it. And when we create a branch and we put multiple commits on that branch, it's actually sort of like a linked list. Forgive me. And every commit has a pointer back to its previous commit. Right? And let's just call this XYZ. And then up here in the commit tree or head, what we actually have is a pointer to the most recent commit on a branch. And let's explore the .git directory a little bit to see how this works. And let me go ahead and close this out. So you never really want to modify this .git directory that gets created when you make a Git repo. And you never really need to go into it, but it is interesting to see. And we see there's a couple things here. There's a file named head. There's a config. And if we print out the config, we see there's things like the git URL, the fetch. There's some information for the main branch. And then there's some other directories. Let's take a look at this file named head. And if I print that out, it says this interesting thing, refs/heads/main. And as it turns out, there's a directory named refs. And if I go in here, we see heads, remotes, and tags. And if I go into this heads directory, I see here a file named main. And if I print that out, I see a commit hash. And as it happens, that is the exact same commit hash that we have up here for our most recent commit. Now, if I go ahead and make another commit, and let's go ahead and let's create a .env file. And let's put some data in it, and I'm just going to make up some data. And let's go ahead and let's use these environment variables. We're going to have to import Python's OS library, and then we're going to need to install the .env package, and then we can say from .env import load .env, and we can then load the environment variables from that .env directory. And just for fun, let's print them out to make sure that they're there. And let's just print out the first one. And we can grab the second one too. And now if I type git status, right, I have these two changes, the backend app py and .env. And let me go ahead and add them to our working directory. Right, so git is tracking that we've modified one file and that we've created another file. And I'm in the zone and I'm coding and I'm not really thinking, and I do git add dot. And now both of these are in the staging area. They've been added to the index. And now I do, and if we look at source control here under changes, we can in fact see stage changes and we can look at the difference, which can be useful. I do really recommend using git status. I can do git diff on the command line. If I want to look at the changes to a file, I could do git diff backend at py. And right now, there's not a lot of changes because we've added them. And I'm going to go ahead and I'm going to commit these changes. And we'll just add a commit message here and we'll say create and use env bars. Right? And so far so good. Except as you guys have probably guessed, I made the mistake of committing my .env file to my repo. Now, the good news here is I haven't pushed that commit yet, and we'll see how to tackle that in just a sec. But before we do that, let's look at a couple things. We now have 3 commits on this branch, right? And so let me update our TL draw sort of branch diagram. And we'll pull this over here and we'll see why in a second. And we'll call this commit. Does it have a commit hash? It does. It's just a pain to pull up. Commit DD54. But let's look at that refs head file again. And I believe it was .git / refs / heads / main. Well, now it's changed. Before, this ref or reference had the commit hash over here. But now that we have a new commit that's at the head of this branch or most recent, we have a commit hash over here. Right? And so this is how Git keeps track of branches. It uses a reference or ref that has a hash to the most recent commit on a branch or the head. And then each commit points to a parent commit, to its previous commit. And if I was to make a new branch, and let's say we modify the README file, and so now we've modified our README file, and let's go ahead and add that change. If I type git status, I see that's there. Excuse me, I apologize. For some reason, TailDraw really wants to like double click into things. We'll get it. Give me 1 sec here to grab this. Yeah, we'll do it this way. There we go. So we've modified it. Let's go ahead. I type git status. I see I'm on a branch, new branch, changes to be committed, modified readme MD. Let's make a commit and we'll just say update readme. And now this has been committed. And let's take a look at our Git graph that we have floating around here somewhere. If we close out a couple of these files, and in fact, let's just go ahead and pull it up. So I have a new branch, and you can modify this so it only shows some branches or all branches. But the way the new branch works is this commit just points back to the previous one. And so from Git's perspective, there's actually not a huge difference right now between our new branch and the previous ones because we haven't done a lot of stuff. There is, however, one very important difference. If I go into my .git directory and I print out that head file, note that the ref has changed because I'm working on a different branch. Right? And if I check out my other branch, my main branch, and we print out that head directory, it goes to main. So when I change branches in Git, all that Git is doing under the hood is this head file in .git points to a different ref or reference, which holds the commit hash that's the most recent commit for that branch. And if I print out cat.git /refs/heads, we, excuse me, let's do ls. We now have two things in there when we only had one. When I created this new branch, it created a new file to track the head for that new branch. And now, if I print out that head, it has the same commit hash as our most recent commit here. Tom, yes, sir.
We saw it yesterday, but where would git stash play into all of this?
Yeah, that's a great question. Let me let me demo Git Stash in just a second. Let me see if folks have other questions here. And let me show how to undo this commit because I want to show that, and then I will circle back to Git Stash because that's an excellent thing to see. The short answer is Git Stash is sort of like a temporary holding area for anything you want. What other questions do folks have around this idea of head and refs and what Git is sort of doing when we make multiple branches? And we have, let's have Git slash refs slash head, right? And we now have main, and we have new branch. And so whenever I am making a commit, Git will update the head of a branch. And it does that by storing it as a ref or a reference. And it does that by just storing the commit hash of the most recent commit on that branch. And then it uses that .git slash head to show what branch we're on. And you're not going to need to ever modify this stuff, but I think starting to see a little bit more of the Git internals helps to demystify it a bit. Let's go ahead and let's fix our error here. And then we can see Git stash, and then it might be time for a short break. So I did make one error here, right? If I type git status and I'm back on my main branch now, right? So in fact, this guy is sort of off to the side because it's a separate branch. So let's pull this guy even further away so we don't have to look at it. And so we can kind of know that it's a separate branch. And if I type git status, my working tree is clean. I'm ahead of origin main by 2 commits because I haven't pushed yet, which is good because we have a problem. And if I type git log, we see create and use env vars, and I mistyped the message, but that's okay. And just to refresh ourselves, let's look in git graph just on the main branch, and let's look at the changes that we made here and see what the problem is. My app.py code is fine, but I committed the cardinal sin of adding my .env file, and even worse, I've committed it. Right? So now, how do I safely undo this? And to look at this difference as well, we can use a command called git diff. And this lets us look at the difference between commits. And we know that head is a reference to the most recent commit. I don't have any new code I've added, so there's no difference there. If I wanted to compare the most recent commit to the commit one back, I could do head tilde 1. And I'm now looking at the difference between, and let's go back to my graph here, this commit and this commit. If I wanted to look at the difference between the most recent commit and 2 commits back, I could do head tilde 2. And I'm now looking at the difference between this commit and this commit. You can also add an actual commit hash in here, but I usually just do it this way where I'm looking back maybe just a couple commits to help orient myself. So now we need to uncommit this .env file. And I believe git reset soft is going to be the command that we're going to use. I'm going to double check this because they in fact have changed some commands. And in fact, the internet is sort of confirming that I'm still on track here. Right? We can use git reset soft to move the head of our branch back, and we don't lose work. And so we can undo the last commit while still keeping changes. And so to visualize this, what we're going to do is this commit right here. This is the one with the problem, right? So this has the .env file that I don't want to lose. Let's say I've done some additional work. Right? So if I type git status, we now have a change to @py that's in our working directory. So I have a lot of different things going on here. So first off, there's never a downside to making a backup branch. And now I have a backup branch that has all of these same changes. Git has just made a new head for it. So what happens is now when I switch back to my main branch, and you can use dash to switch between branches, by the way. If I do something really silly here, because I have the backup branch and git tracks changes, I can always use the backup branch. So I recommend making a backup branch if you ever just feel uncertain about what to do next. So now we're going to run git reset soft, and we're going to tell it to go back one commit. Right? And so our steps here, and in fact, I'll put this in the README, how to safely uncommit code I haven't pushed. We use git reset soft. First, we make a backup branch. Then we uncommit our most recent commit with git reset soft head tilde1. Then we can use the git reset or git rm staged that we learned about already, and then we can make a commit. And let's watch this workflow in action. So I'm going to do git reset soft head tilde1, then type git status. Note that my backend @py changes are still there. They haven't been modified. Note that this stuff over here is no longer committed. We've kicked it back to the staging area. Right? And if I use source control as another way of seeing this, I can see that it's like I've just added these. And now what I can do is I can use that git restore staged to unstage. And I just want to unstage the .env file. So I'm going to do git restore -- staged .env. And now if I type git status, we see that we still have those backend @py changes that from my previous commit, which I want. They're still staged, so Git still gives them some protection, but I've very specifically unstaged .env. And this is a completely safe operation, right? We've gone through a couple steps here. There's been a lot of explanation. I made a backup branch just in case, but by using this git reset soft, head tilde1 to unstage our most recent commit, or to uncommit our most recent commit, And then by using this git restore staged for a specific file, I can really safely do this. And because I'm not manually changing code, there's very little chance of programmer error, right? I have these steps written out in the workshop curriculum file as well, because I realize that that's sort of the key thing here. And again, because I have the backup branch, even if I made a mistake, I have a backup branch I can go to. And also because when I'm using restore staged, I'm doing it with a specific file. Worst case, I just screw up that one file, right? So this is a really safe way to uncommit code. And now, in fact, let's go to our git ignore directory and let's add the .env file because we don't want .env checked into version control. Let's, in fact, also make a .env.example. And let's go ahead and we'll open these two up. And this is how you can document for other programmers your .env files is a .env.example file with made up values, right? And in the real world, these would be real values that you can then check into version control. So now let's go ahead and let's add the .git ignore. Let's go ahead and add the .env.example file. And let's not add the other changes because this is really separate work, right? This was sort of a new feature I'm working on. Well, this is the stuff I was working on before. And now I can go ahead and let me go ahead. I'm just going to copy these and put them in the staging area just to kind of simplify stuff a bit because I have a lot of things happening all at once. Right, we have these new files and we're going to go ahead and commit them. I will just say git commit -m and we will say don't put env in git ignore. Right? And now this is here, and this is in fact a brand new commit with a new commit hash. If I type git log, we see it's commit, 01 fd something 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 something. And if I look at my git graph, it starts to get a little more interesting. Where let's see main and new branch together. And now the graph actually shows a divergence because new branch, when we branched, it was off of the old version. And on main, we've actually moved ahead, right? So if I cared about new branch, I'd have to merge main into it. I'm not going to worry about that right now. We'll talk about merging and merge conflicts in the other workshop. But here we can see how the branches do start to kind of diverge. And now I am going to go ahead and push this code. And I do recommend just kind of pushing code after every commit. So I just want to pause and check in here and see what questions folks have or what people are curious about. Because I've been doing an awful lot of talking here. So I just want to know, is this useful? Is this a lot of information all at once? What's on people's minds? Rick, yes, sir.
And yeah, it's a lot of information, but I'll probably end up watching this again. I've also watched a lot of advanced YouTube Git tutorials, which it's got the same kind of stuff you're showing. So
Yeah,
it's very informative. It helps to get around Git, because you make an error and your your commit, and it gives you a little bit more ability to like go back if you mess something up.
yeah, totally. So I recommend in the workshop repo here, while it is a tutorial, what I also have in here is, if we scroll down, here we go, like explicit steps for that workflow we just walked through. And this might be easier for you guys to look at as a reference, like if you find that you need to uncommit something. I also recommend, I really, really like that Git from the bottom up. I think part of the challenge with Git is just that there's a lot of moving parts and kind of understanding it. And what I found is that with Git, I think you just got to do the deep dive into how it's working, and then things will really start to click, though it can be a little more painful. Let's go ahead. Why don't we take 5? And then when we come back, I'll show how to deal with I've committed code, I've pushed it. How do I undo code that I've both committed and pushed? We'll also take a look at Git stash, and I think we'll have enough time to look probably at like Git revert and maybe 1 or 2 other sort of stretch things. Sound good? Awesome. Thank you all, and I'll see everyone in 5 minutes. All right. So we saw how to use Git RM cached, which I always have trouble spelling, to unstage anything we've added, right, to the staging area, the index. We've gotten a good sense of the working directory, the index, and the commit tree or head. We've seen sometimes it might be Git reset cached instead, or Git revert. That's kind of got a lot of commands that are sort of overloaded. We dove into that .git directory. We saw that inside that .git directory, there's a reference or a ref called head. And there are other kind of references other than head. You can make something called a tag for like different versions, which is a little out of scope for right now, but it's cool to learn about. And when I change branches, this is what changes. And then also inside that .git directory, there's the different references. And the one that we care about the most is this directory heads. And if we look inside there, we see that for each branch, it keeps track of the most recent commit on that branch. And so this is the head of all of our different branches. And so this is how Git knows the most recent commit on a branch. And then this head file is how Git knows what branch I'm on. And we've seen this Git graph tool, which again, you can install as an extension. And I highly, highly recommend you do. And I would just have it open while you're working on projects and stuff. And we can see here all of our branches. If I wanted to look at just one branch, or maybe just 2 branches to see how they diverged, I could do that. And it's a pretty useful tool, and you can look not only at the sort of diagram, but it shows you the commit hash, the parent commit, and you can look at the changes that happened in that commit as well. All of which is stored in various places in that .git directory. So as I'm looking at this and I'm looking at my repo, here's the repo for our workshop, and I'm taking a look at it, and I realized, well, I pushed up the most recent changes on my main branch, and let's just do git push just for fun to double check, and everything is up to date. But there's no backup branch, there's no new branch, right? I created a couple branches along the way here. And if I type git branch, which just lists out all the different branches, I see that we have these 3 branches that I've made: main, new branch, backup. There's no downside to pushing these up, right? By pushing them to GitHub, I have my backup backed up on GitHub. And new branch, I can't remember. Maybe there's something that we want. You know, I also have some in progress work here. It says uncommitted changes. And if I type git status, we see that there's some changes to the README and backend app py. And if I type git diff readme.md, I see the difference between my unstaged changes in my working directory and the most recent commit. Right? So that git diff command is really useful. And I can use it to compare what's in my working directory to my most recent commit, or I can use it to compare one commit to another commit. And if I just type git diff, it will compare for all the files the changes. So, before I do anything else, though, I want to push those other branches. Let's go ahead. Let's check out that backup branch. And notice we see this we see switch to branch backup. And if I type git status, I still have my unstaged changes here. And let's just go ahead and let's do git log just to remind ourselves of what happened here. And we just have, various stuff going on. And I could look at my backup branch here as well. And let's just go ahead and push that one up. And we need to set up the upstream remote, no problem. We push it up, all good. Let's go back to my main branch with checkout space dash. And now we also have, there was that new branch, right? So let's check out that one and push it up as well. So its changes are there on GitHub too. Here, I'm running into a problem. And this is where we're going to see git stash, in fact, in action. I tried to change branches, but Git won't let me. It's saying, hey, if you do that, you're going to overwrite your working directory changes to your README. I added all this stuff in the README. I think Git's highlighting it here in green. It's not added or staged. It's not committed. And in this other branch, if we go and examine this new branch here, and we look at the README, it has a different version of the README file. Git is not going to try and be clever and mush stuff together. It's going to tell me these two things are different and I don't know what to do and I don't want to lose anything, so I'm not allowing you to change branches, which is good, right? This is actually what we want. So how do I solve this? It says, please commit your changes or stash them before switching branches. Now, if I was done modifying my README here on the main branch, I could add it. I could add it, I could commit it, and we don't have a problem. But I'm not done. I'm in the middle of my work. And this is where git stash comes in. And git stash it's basically like a holding area. It's like I want to stash something off to the side for a minute. Sorry, it keeps wanting to do that. So let's type git stash and see what happens. It says saved working directory and index state on main, blah, 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 blah. If I type git status, that stuff is gone. Where did it go? It went here into the stash. And the stash is actually a stack data structure. I do git stash help. Stash the changes in a dirty working directory, blah, 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 blah. And we have this git stash list option. And there's a whole bunch of other things. And we can see here the things that I've added. So if I had if I was stashing lots of stuff, I might Git actually does this as a stack. Like the next things that I stash would be, sorry, TL Draw is just fighting me today. If I stashed more stuff in here, it would be there, because the command I use to get something out of the stash is pop, which we've learned about when talking about the stack data structure. And the pop command grabs the most recent thing off of a stack and pops it off and brings it back. Now, and so git stash pop brings me back those changes. Now, in practice, I have been using Git for over a decade. I don't think I've ever put more than one thing in the stash at a time. And I don't recommend doing it. Just keep it simple. And what it's really good for is a situation like this, where I'm not done working on my code, right? I've got work in progress code that I haven't added or committed yet, but I need to go over to another branch to do something real quick. And I can't because that would mess with my code in progress. So I run git stash. I throw the things in my working directory on the stash. I can now do git checkout, new branch. It's safe, right? The working directory is clean. My work in progress code is on the stash. I can now push up my new branch, and we'll follow this command, and we'll go ahead and do that. And now let's hop back to main. And now let's do, and by the way, note what the README file looks like right now on main. And let's see what happens to the README file when we run git stash pop to get our changes back. And now we have those changes back. Right, so git stash, it's really, you run git stash, you throw something in the stash, you switch to another branch to do whatever you need to do or whatever you needed to stash it for. And then when you're done and you want your work back, you run git stash pop. And I just want to check in and see if folks have questions or stuff that we're curious about. Okay, cool. Let's go ahead. Let's commit this code. And in fact, we might as well add to the README. Here we can say git stash, and we use it to stash work in progress code in our working directory. And really, we run git stash, we do whatever we need to do, and then git stash pop to get the code back. And that's really all you want to use it for. If you, like I said, I've never had to do anything more complex with it, but this is super useful. So let's go ahead and let's add those changes. And we had some changes to app py. That was important work. This is important too. In fact, let's just go ahead and add that as well. And we have a bunch of changes here. Let me type git status. I've got things committed. Let's go ahead and commit. Remember, you know what? I want this work to be separate. I want one commit for the README changes and one commit for backend app py. So let's do git restore -- staged, and let's move the backend app py stuff back out. Right. So now I'm going to have two different commits. And this is nice because I can have my git commit messages be more specific. Right? And this README work has now been committed. It's now on the commit history for main. And now my important backend app py work. With my important backend code, I can go ahead and push it. And if I go over here and I look at my commit history on main in the code that I've pushed up, we can see that I have these two small clean commits. Now, why do I care about this? Well, let's say I realize that I've made a mistake and I pushed code that I don't want. And I don't want this most recent commit, I have a couple options here. And it can be tricky. I could just modify and delete the code, but if this is like 100 lines of code, that might not be easy. And maybe I want to keep this work, but not that work. So I could do git reset soft head -1. And let's grab these and let's do git status. And I've now moved, let's get rid of this. I've now moved these changes of mine back into the staging area. And let's do git restore -- staged. And now these changes are here back in my working directory. But I want to keep one line and I want to get rid of the other. And again, imagine a scenario where you've got like 50 to 100 lines of code. Maybe it's spread across 3 different files, right? Because if it's just 2 lines of code, I can just manually modify it. So this workflow is really about, I have a commit with a bunch of changes and I pushed my commit and I need to undo something. And, maybe this is a production environment, or there's other reasons why I don't just want to modify the code. Why I want to kind of go through this dance and actually change the commit history. Maybe I've committed and pushed a .env file by mistake, along with a bunch of other things in one commit. So let's modify our work. You know what? I don't want that line, but I do want this line. Right, so now our change is just this. And we're going to go ahead and add it. And we're going to go ahead and commit it. And we're going to say fix app py important work. And if I look at my Git history, right? Update readme, fix app py important work. And let's go ahead and push it. And now we see an error, right? And this error says updates were rejected because the tip of your current branch is behind its remote counterpart. So what's happened here? If I look at my main branch on my computer, my local Git repo on my computer, and I look at the main branch that we have pushed to GitHub, they are different, right? Because this most recent commit has these 2 lines. Mine just has the 1. And Git is telling me there's a difference here. I don't know how to fix it. It looks like your local branch might be behind, but I'm not really sure. Now, I know what I've done. I've modified a commit, and I know that my version of the code is the truth, right? That my local Git repo has the version I want. I can do a force push with -f. This is really dangerous. When you're collaborating, this is really dangerous. If you're doing it by yourself on your own branch, it's fine. But this will modify the commit history. This commit here with these 2 lines, we are about to lose forever. So I've committed code and I've pushed it and there's something in there I don't want. One option is a force push. You have to be really careful. If you're doing it, you have to know it's on a branch that's just yours, that no one is collaborating on. And you need to be certain that you're not going to lose work that you want in the other commits. Because this commit is about to go away and be replaced by this one. And I have told Git, push all of the commits on my local repo up to the remote repo on GitHub and override the remote repo. And note that that important backend code commit is gone, right? It's now gone forever. We've lost it. So if it's just me and it's my own code, I will force push all the time on my own branch, but you do want to be really careful because you are modifying the commit history and you can't get that back. And you would never, ever, ever do this on like a main branch or production branch, and what we'll talk about, or a shared branch, which we'll talk about more in the second part of the workshop. But it's a useful tool to know. But again, this is where you really want to slow down and be careful. Like I would definitely make a backup branch before doing a force push, and recommend you guys do too. Because again, there's no downside to making backup branches. And that way, if I screw up, then we've got the backup branch. So there is another way to accomplish this task, or a similar task, and that's called git revert. And git revert will undo a commit. And let's look at this readme commit. And let me grab the commit hash here. And let's just do git diff. And let's look at that change. And it looks like there's a change to app py. Let's just do, let's pull up git graph and let's play around with git revert a little bit. So let's say I decide I want to undo this most recent change. I could use the command git revert, and let's do head tilde1. And we're saying, look at one commit back. Actually, let's say head and undo it. And it's telling us the commit that it's going to undo. It's auto-generating a message, and I would recommend just leaving all this as is because it's got the commit message and the commit hash, and this is the history that you want. And if I type git status and git log, we see there's this revert commit. And if I go to @py, I see that message is gone, right? That was over here. But the interesting thing is, let's see how git did this. I still have that commit from before that added those 2 lines of code. What git did was generate a reversion commit that just undoes those 2 lines of code. And just to play around with this, like, let's add something to @py, and we'll call it like, we will revert and unrevert this. And let's add another comment here. We will also mess with this comment. And in the README file, let's add something here. We will mess with this line with git revert. And if I type git status, I've got some changes. Let's do git add, let's do git commit, and we're going to call this like mess with reverting. And so now let's do, and let's push this code because why not? Let's do git revert head. And let me go ahead and do a split here. And let's pull up @py and the readme. So let's do git revert head. Let's go to the commit message. Let's save it and quit it. Note that those messages are gone. If I look at my git graph, let me pull up here in sources. So let's get that. Let's get rid of that. So I have a reversion commit that undid those changes. But it's the previous commit is still there and it's in the history. And in fact, let's revert our revert. And now we can bring them back. And let me get out of this so we can see @py, and we see them, and this line and this line and this line are back. And if I type git log, I see I've got the reversion, and then I've got reverting my reversion, and let's just revert it again because why not? And now those lines are gone. right? And so this is kind of cool because if you have one commit that has exactly what you want to get rid of, git revert will just get rid of those lines of code and there's no chances of programmer error or typo. But if you don't have like one clean commit with what you want, then you're not going to really be able to use git revert to do this. And the nice thing about git revert is, again, there's zero chance of programmer error. And I have all of that code here in previous commits and in the commit history. Right? So you don't need it very often, but when it is the right tool for the job, it's a great tool to use. And because the commit history has not been modified, we're just adding more commits. I can push it up. There's no conflict. There's no need to force push. So I just want to check in here and see what questions folks have and what people are curious about here with git revert. Because this kind of gets to the idea of git and commits as immutable, and it kind of touches on some key concepts. And do people feel like the idea of what git revert is doing, like you guys are pretty comfortable with, or does it kind of feel like I think I need to kind of go over this? Somewhere in the middle, maybe? Cool. Again, the goal for today is really to show some workflows and tools for building confidence as you're working on bigger projects like your personal project with Git, and to get more comfortable with commits. Like we've gone pretty deep and we've done some pretty advanced stuff. This is also here as a reference that you can see. And again, if we kind of look at this git revert, here was like the original commit I made that modified my two files. By using the git revert command, Git looked at a specific commit and just deleted those files, but it just did that automatically for me. And because it's another commit, while I got rid of what I don't want, we have that change still in an older commit. And because Git keeps track of deletions, we can mess with reverting our reverts, right? Because Git keeps track in commits of what was deleted. So in this commit, we're just adding back in what we got rid of before. So hopefully that breaks it down a little bit. Again, I have an initial commit here that made some changes in some files. With git revert, I can tell it look at a commit and undo those changes, delete those lines. And so this commit tracks deletion. And then I say, hey, undo what you just did, right? So we're undoing the deletion and it's adding those lines back in. And I said, you know what, let's revert that again. Let's undo what you just did and delete those lines again. And again, if you think about this being maybe like 50 lines of code spread across 3 different files, you could see where this is useful because there's zero chance of programmer error in terms of like messing with the files. And worst case, if I screw up and I realize I need to go back in my commit history to a previous commit, I lost something, and I actually want to go back in time to this one for whatever reason, I can do git checkout and I can give it a commit hash. I could do like head ~forward to go back 4 commits or a specific commit hash. And now that I've checked out a previous commit, I don't really have a head, right? Like if I kind of look at this commit history here, what Git does for me is, it always usually it has that ref, right? It has head. And so when I check out a branch, Git knows where to go, right? It goes to the head. but I'm not using the head. I'm telling Git like, hey, go back to this commit or whatever random commit I want. So it calls this detached head state. And as it says here, if I want to make a new branch to keep the commits I create, I can do so now or later. So, it wants me to use this switch command. You can use the branch command too. The switch command is just sort of a newer command, but we can do git checkout dash B, my new branch from old main, right? And if I look at this new branch that I've made, and let's look at my new branch from old main and main, and let's change something here. Let's change the README special change on new branch from old main. And let's do git status and git add and git commit. And we'll say add README. And we got to push the upstream fork. But now we can kind of see, and hopefully this visualization of the graph helps illustrate like going back to a previous commit, right? With that git checkout command where I went back to a previous commit. I decided this is where I want to work on a new branch from. So I made a new branch off of that previous commit. And then I made the change I wanted. There we go. I made the change I wanted, I committed it, and I pushed it. Right. And so now this is a more advanced scenario. You will rarely have to do this, but I just want to emphasize that reverting is a really safe operation, while force pushing is not. And worst case, you can always go back in time to a previous commit and create a new branch off of it if you need to. So I think this is a good stopping point for today. And I just want to pause and see what questions folks have. If there's anything that you guys want to dig into a bit more with this, if there's questions around workflow or like how does this matter for my personal project, or anything else with Git that you want to see. Okay, cool. And just to recap, I've gone into some pretty advanced stuff here. You almost like you use this stuff like 5% of the time. But when you need it, it's really nice to have. It's really nice to have when you need it. Again, I'll share the link to the curriculum here, but the goal of today is really to dive deeper into Git so we can be comfortable with these scenarios of I've committed code that I don't want, right? Where I added code, but I haven't committed it yet. And what's my workflow for safely undoing it? I've committed code that I don't want or I need to change, but I haven't pushed it yet. Or the trickier scenario of I don't really touch it, we don't go into it that much, but I've committed code I don't want and I pushed it. Right. And we've seen that we can use git revert to just straight up undo something and have it be safe. The force push is a bit more of a dangerous operation. And so these, I think, are really on a practical level, the three scenarios you might encounter on your personal project or bigger projects. And the goal of today is to set you up to be a bit more comfortable. Git is the one thing where you don't really want to mess around. Sometimes I might have to take like 20 minutes to read up on a Git command before running it. And I do recommend that, right? Because if you're kind of in unknown waters with Git, you can kind of paint yourself into a corner pretty quickly. So with Git in particular, it's better to go slow and take your time. Ryan, yes, sir.
Yeah, kind of not on with today's topic, but in Git in general. So like in a lot of like job descriptions that I've seen, they they require like knowledge of Git. And like in your experience, like do you have any idea like what in general that means, or like what they're really looking for when they say that?
Yeah, absolutely. So what is the number one job of Git, right? The number one job is to help us back up our code and keep it safe. The number two job is for us to be able to have different versions of our code. And the number three job is really for collaboration. And so, first of all, it's this understanding that version control tools like Git matter. There's other tools out there, but like if I'm a software engineer, I don't want to just write code and have it live in a file. That doesn't give me the reliability and control that I need as a professional, and I need a version control tool. Then as my program gets bigger, I want to have control. I want to be able to have an experiment branch so I can try out a new feature that doesn't mess with like the live app in production. So I can not break existing code, because if I'm working for Amazon, breaking Amazon.com is not an option. And then there's collaboration. So really those are the three key things. And then on a practical level, it means being comfortable understanding what a repo is, understanding how Git works, understanding branches, making commits. Up until now in the course, because you guys are really learning Git, we don't really emphasize like sort of best practices around commits, but there's a whole approach where like a commit should be a small self-contained unit of work. It should have good commit messages and stuff like that. And I've pulled up the GitHub repo for React so we can take a look at this. And if we look at here we go, whatever the heck this commit is. So you can see that there's a lot of thought that goes into the commit message, because for a really big project, this is actually documentation for other developers, right? And in fact, this one, and you don't want to commit to be too big, and you want to commit to be specific. And you could see how if you have a really big project with like dozens of people working on it, like this kind of like best practice and discipline is more important. And so here we have a pretty specific description of what this commit is doing. I have no idea what the back to full tree view in React DevTools is, but they are moving it. And that is what this commit does, right? And because that is all that this commit does, if I made a mistake and somehow that error slipped into production, a DevOps engineer can use like git revert to undo this one commit, and it won't break anything else. And you can see how sort of like they're connected to pull requests with bigger issues. And there's a pull request here just for this one thing, right? And we can see this is more about GitHub and collaboration that we'll talk more about in the next workshop. But you can see how someone creates an issue here, which is not unlike a story. Let's actually go back to, let me make sure I've got the right thing pulled up, because it seems to be going somewhere else. I guess they linked a PR to a PR here, but somewhere, if we dig deep enough, there should be a GitHub issue. Yeah, so somewhere in there is a GitHub issue, but you can see how even like when I'm working on code and I've worked on a branch and I'm making a pull request, there's a pretty big description of what's happening. And there's a lot of discussion around it. Like if we go back to this other issue, we see that there's a description of the problem, a link to the issue it resolves. They, as a front-end engineer, I would often make video screen recordings of the feature that I made so that whomever is reviewing my code can really easily see what it's supposed to do, because senior engineers are busy. They've requested a review. There's a lot of automated stuff. It's been merged. There's no discussion on this one. You can see here they've got like 240 tests running. But all this, right, just for this one change to this one file, right? So this is a lot, but for a big project that if it breaks has a lot of downstream negative impacts and you have a lot of people working on it, when you have a team that's working in this way, you get like more reliability. And I realize that that's a bit out of scope for Git, but I think hopefully is it useful to sort of like see how it plays into the bigger picture here? And if we look at like some of these pull requests, for example, and let's look for most commented. And here's something for some sort of, I don't know what a synthetic keyboard event is. The keyboard event is a mouse click, but we can see here that someone had made a GitHub issue, which is a lot like a user story, but a little more granular. And it looks like this one is a bug, and someone's reported what the problem is, what the expected behavior is, what version of React this is for. This I think is actually, I don't know if that's Dan Abraham, like one of but this is one of the core maintainers of React who works for Facebook. And then someone, I don't know if they work for Facebook or if they're a volunteer since it's an open source project, has taken that issue in the description. They've worked on it, they've made the fix, they've documented it. We can see that they've changed some files. It's just one change, it looks like in one commit, but I'm guessing there's a lot of work that went into this. And then we see that there's a lot of automated stuff here. I don't know if there's actually any human conversation on this one. Let's see if there's human conversation on one of these others, because these days there's a lot of like bots and other things that run automated tests or do things on pull requests. But here we go. Here we can see there's some back and forth discussion as part of a code review for whatever this particular change was. Right? And they're asking them to add a test. And there's just more and more and more and more and more back and forth. And again, the senior reviewer is saying like, this is good, but we need to see some more work. Here's some of the issues. Here's what we need to have happen. And if we scroll all the way down, eventually this was reviewed and approved and merged because it was merged in, right? And to go back to Git and GitHub, this is all work that's done on a branch. I will talk about these sort of branching collaboration strategies either. Note that it's just 2 commits, right? One fixes an error. And in fact, when you're reviewing code, I will often look through the different commits. And if they're well organized, it makes it really easy to review that code. And in fact, GitHub has a button here to go to the next commit. There we go. Let's go to the other commit. And then we can see the other commit, right? So I wouldn't worry too much about making like really clean commits for your personal project. I think you guys are still really just kind of getting Git and GitHub under your fingers. But then when you join an engineering team, this is a pretty normal part of the mentorship process for junior engineers, where it's like you learn like how the company wants you to make your commits, like what the standards are around these sort of pull request reviews and discussions and stuff like that. I realize that was a bit far afield, but Ryan, did that help sort of answer your question?
Yeah, I think so. Thank you.
Yeah, absolutely. Yeah, so I think I'll drop this link in actually let me drop this in the Zoom chat, and if someone can repost it in Slack, I'd appreciate it. We'll see this especially in the group project where once you guys start collaborating. But again, I think it's just starting to think about like the bigger picture of writing software, that now that, I have my app over here, like this commit history isn't just about helping me keep track of stuff. This is about like, what if my app is deployed and live, but I realize that this specific commit has an error and it's running on a live server. If this one commit is just about one specific feature, I could use git revert, push that change up to the live production environment, and have that be a very safe operation. If this commit stretches across more things, then fixing that bug in the live production application becomes more complicated, right? And again, that's a bit more advanced, but this is the right time to start thinking about that stuff. Yeah, hopefully that's helpful and not too deep a rabbit hole. What other questions do folks have, or are people curious about with Git and GitHub, or really anything else that we've been discussing? All right, folks, thank you very much. We will look at collaborating with Git and GitHub, and we'll talk more about pull requests and branches when we do another workshop closer to group projects. I'll share the demo and notes code in just a bit, and hopefully this is useful. Thank you, guys.